So let's look at the many ways of presenting data. So we'll start with line plots. So here we go. Data shows the daily max temperatures in Barcelona in June. There they are there. And to do a line plot of that, we would just have our scale, temperature, note it from the smallest to the highest or close to the highest. And then we would just simply, where 27 occurs, place a dot, where 28 occurs, place a dot, and so on. And we would get our line plot accordingly. Okay, and just to note that this value here is an outlier in the data set, okay, because it's not close to the rest of the data. Okay. Now, the range of the data is 19 degrees. Ranges from 19 to 31 degrees, so that's 12. The mode is 28 because it occurs most frequently. There it is there. And 19 degrees C is the outlier. And we can say really that the temperatures are bunched or clustered between 25 degrees and 29 degrees. So they're bunched or clustered here, in that area there. Okay, that's how we'd comment on that line plot. Bar charts, they're a series of same width bars drawn vertically or horizontally, so they can be like that or they can be like that, either way. Okay, the height or the length of the bar represents the frequency. Okay, sorry, as if there. And the bars can be separated by narrow gaps of equal width, as you can see here. Okay, and you can use bar charts. You can arrange the data using class intervals as well. So 1 to 5, 6 to 10, 11 to 15, and so on. Now, just while we're here, histograms then. There's no gaps. You can see there's no gaps there. What's the difference between, well, not histograms and bar charts, we may as well consider them together. Histograms are used to show continuous data. The data is always grouped into classes, and the area of each bar represents the frequency. Okay, and they can have equal or unequal class intervals, but in our course we just look at equal class intervals. And the modal class is here. It's again, there's more in this class than any other. It's the most frequent. We'll come back to histograms in a minute, but let's just look at pie charts while we're here. Let's look at pie charts. Bear with me. Okay, so pie charts, they're good for categorical data where the slice of the pie represents the share size of the data. So how do we do a pie chart? Remind ourselves, in a survey, 72 people were asked what heating was used in their home. So here's the 72 people, 6 solid fuel, 12 electric, 24 gas, 30. So how do we do the pie chart? We need to find the angle of each sector, and we do that by saying 30. The angle of the pie chart for oil is 30 over 72 times 360 degrees is 150, and we'd start here, mark an angle of 150, and that represents oil. Gas is 24 over 72 by 360 is 120, so we carry on around there. Electricity is further 60 degrees from here, and then that just leaves the remaining 30 for solid fuel. So now let's bring our attention to the shape of data distributions. So if we were to draw these histograms based on data, and the data stayed very much in the lower range, or it moved much towards the higher range, or was in several different ranges, then we would say that that data is skewed. Okay, this type of distribution represents a more balanced, it's more symmetrical, it's a more balanced distribution. Okay. So, common shapes. Here's the most important shape in statistics. It's symmetrical and it's known as a normal distribution. Okay, and it can represent the heights of random people or the exam results of random people. It can be a distribution drawn from any set of data. And the important thing about this normal distribution is that the mean of the data is equal to the mode is equal to the median. Okay. The second type of common shape is a shape that has a positive skew. Okay, and we say that it's skewed to the right. Its tail is on the right hand side, and you know the important thing about this data is that the mean is greater than the median, which is greater than the mode. Okay, they're not equal. Okay, and we might see a distribution of data that has a positive skew if we're considering the ages of people when they first learn to ride a bike, and it's very much a younger age rather than an older age. The third type of shape is a shape which has a negative skew, and it's skewed to the left. The tail is on the left. It's a negative skew, and in this case the mode is greater than the median, greater than the mean, or you can say the mean is less than the median, less than the mode. So for a normal distribution, mean equals mean equals median equals mode. For positive skew, mean is greater than median, greater than mode, and for negative, mean is less than. It's negative, it's less than the median, less than the mode. Okay, and in this case, this might be the age. This might represent age. Okay, and the age at which people get their reading glasses. So you can see at a young age they not as many need reading glasses, but as people get older it increases. Okay, so we will have not every distribution is normal. We will have some with positive skew and we'll have some with negative skew. So here's a histogram that shows the ages of people in a village. So going from the babies up to the 80-year-olds, okay, and this is the frequency of how many people in the village were of a certain age. So just for example, between 0 and 10, there were 2 people in the village of that age, okay. And if I get a table and I draw a histogram, I like to put my frequencies on top or inside each box, just so I can quickly refer to the data as I need to. So let's answer some questions about this histogram. How many people are under 12 years of age? Well, are under 30 years of age, so there's our cut-off point there. It's this many, is 12. How many in the village altogether? Then we have to add up all our frequencies. Add all the frequencies, that's all the people they asked, it's 60. Which interval value contains 20% of the people? Well, what is 20% of the people? It's 20% of 60, it's 12. So it's this interval value here. And what is the probability that a person selected at random is between 60 and 70? So the probability of the age being between 60 and 70 is equal to 6, because here's our 60, 70 is this 6 out of 60, which is 0.1. 1 in 10, 0.1. What is the greatest number of people who could be older than 55 years? So it must be in this range here, from the 50 to 60 range upwards, so it must be 21. It's these 3 frequencies added here. And then we're asked to use mid-interval values to find the mean age x bar, okay? So we have to find the mid-interval value of this is 0 plus 10 divided by 2 is 5. The mid-interval value of this is 10 plus 20 is 30 divided by 2 is 15. And you can see these values, I'll make this a bit larger, reflected here. These are the mid-interval values. We'll multiply those mid-interval values by their frequencies and we'll sum them all. Okay, and we divide that by the 60 people in the village, and the mean average age is 43.5 years. And now let's look at stem and leaf plots. Stem and leaf plots, they give an overall picture or the shape of the distribution on all the data. They show all the data at the same time, and they also give the shape of the distribution. Because here's, for example, here is the shape of this distribution. Okay, and the numbers actually form the bars themselves. Okay. So here's an example. Use stem and leaf plot to show the ages of 21 musicians in an orchestra. So there's the 21 musicians, 21 bits of data, there's their ages. How do we do that? First thing we have to do is find what is the range. The range goes from 25 to 56. So we have our stem and our leaf, and we write down from 20, 30, 40, 50. We put our key to indicate that 2, 5 was equal to 25 years of age. And then we go through the data, and where we see 25, we put 5. Where we see 8, 8. We look for more 20s, 8 again, and so on. I keep filling in accordingly. That's unordered, so we like to order it. So we just rewrite our stem and our leaf, and this time we'll just put our 5, 6, 8, 8, 9, 9. It's just be easier to read, okay? So let's find the mode. What is the mode? The mode's the most frequent, isn't it? It's all these 5s here, but that's not 5, it's 35. The mode is 35. And the median is the middle value. Okay, so where is the median? We've 21 musicians, must be halfway, it's the 11th value. What is the 11th value? If we count our way up here, is 35 as well. So the mode and the median are 35. And of course the mean can also be calculated for this data as well.